Assalamualaikum and good day to my panelists, Dr. Firdaus and Prof. Dr. Wirashmal. My name is Hadi Afiq and my final year project 2 is titled Development of a Crop Spraying Module for a Multirotor Drone. So here will be the presentation outline throughout this presentation. So first we start with the introduction, then the literature review, and next problem statement regarding this research objectives, research questions that people might ask, my hypothesis before beginning with the experiment, methodology, the results of these experiments, significance of my work, and lastly we end with the conclusion. So starting with the introduction, so as you know, my topic here is related to agriculture drone. So why do we need agriculture drone? This is because the production of crops need to be increased as population is increasing every day. Therefore, they are increasing in demand for agriculture drone as it increases the efficiency of spraying crops. This is because the drone can fly too. A common agriculture drone can have many sophisticated applications such as, and not just crops spraying, they can be crops monitoring, weed identification, soil analysis, and many more. And with many more applications, it becomes more expensive. So we want to focus on making agriculture drones more accessible to many more farmers. This is because certain farmers may not need many agriculture applications. They may only need one goal to solve their problem. So next, here are some of the literature review to support my statement. So first, by Kukete, agriculture drones provide a higher safety measure. It reduces the chance of getting skin disease to a human body if human were to operate the spraying machine. This is because humans, when they operate the spraying machine, they are exposed to the liquid more. So next, by Spalevic, the price of small drones without specific technology ranges from 7,500 ringgit to 15,000 ringgit. However, with technology such as technology for crop spraying, for crops monitoring and others, the price can reach above 120,000 ringgit. Next, drone technology is not entirely yet available for non-expert to use just by explaining what to do. So users may need to learn more. And there are also rarely any education programs and courses that focus on UAV globally. Thus, if there were to be an education programs regarding the drones, the cost might be too expensive. So now we have come up with the problem statement regarding our research. So first problem statement, current agriculture drones are very expensive for an average farmer. So as you know, agriculture drones can cost above 100,000 ringgit. Second problem statement, so if they were to have these agriculture drones, farmers may be confused on how to use all the features available on an agriculture drone. So third problem statement, specific education programs regarding multirotor may not be accessible to some people. So some might need to travel to find this kind of course, and if they were to find someone to teach this course, it might be too expensive. So now we have come up with the research objective to overcome our problems. So first, we want to propose an agriculture drone that costs less than Rm 10,000 ringgit. So second, we want to develop a spraying module that is suitable for multirotor with 5 kg maximum payload. So 5 kg is usually the maximum payload for drones under 10,000 ringgit. So third objectives, we want to evaluate the developed spraying module performance. So this is to make sure that it is efficient for user to use. So here are some of the research questions for people that might be wondering what is this scope of work. So first question, what kind of agriculture application will be available to the proposed agriculture drone? So the answer to that is the agriculture drone will have the most used application by farmers. So this is to spray the crops. So second question, what is a module and how does it work with the multirotor? So some people might not know what is a module. So a module is a detachable unit. It will have its own working system. For example, it can be a spraying module or a crop spraying module, a crops monitoring module. So third question, how is the module controlled? So easy, it is controlled by wirelessly with a smartphone application. So here are some of my hypotheses before start developing my own spraying module. So we want the spraying module to spray crops using a water pump with a jet nozzle and have a misty water appearance while spraying. So next, the total weight of the spraying module should be less than 5 kg with full tank. This is to make sure it is suitable for drones under 10,000 ringgit. So next, spraying module should work individually to make it easier to attach to different drones without integrating the electrical components with the drone. So you just have to attach the hardware, so no need for electrical integration to make it easier for users. So next, here we go with the strategies and limitation of this project. So because we are currently living in the pandemic, so what we did is that only the spraying module was fabricated. We were unable to attach to a real drone and test the spraying module while flying and get the experiment based on the flying data. So as for that, experiment is done to get information based on the spraying module, which is to get the flow rate of the spraying module, the spraying performance while static and moving at a different height. So on the right side, you can see the drone, the renderings if the spraying module is to attach to a real multirotor. So next, here is my technical drawings and renderings of the spraying module. So the renderings is shown as from the previous slide, but for the technical drawings, this was designed from using the software SolidWorks. So the parts that was not designed by me are the pumps, the electric components. So I just download that from GradCAD. This is to organize and determine what are the dimensions needed to place the electric components with the container. So the dimension for this spraying module is the length is 330 millimeters, the width from nozzle to nozzle is 1000 millimeters, the height is 332 millimeters. And what I want to mention is that this hanging part here is where we hang the spraying module with the multirotor. So next, here's my spraying module construction and specification. And on the right side, you can see the fabricated product. So I would like to share the spraying device with you because I have it with me. So here's my spraying module that I made, and as you can see, we have the pumps and the electrical components inside, and this is a connection for a LiPo battery, this one, and the pipes. This is how we connect the pipes with the pump. So it's taken from the tank and will disperse by the pump. And this is what the nozzle look like, which is get by the spraying nozzle. And the container here is get by at home, because I have the container a lot at home, so it's recycled. And this is the hanging part, which and the plates here at the bottom is 3D printed with a PLA material. So here are the overall specification of the spraying module. So it weighs 1.6 kilos without the tank fill, but and the tank capacity is 3.4 liters. So if we add up, it will probably weigh 5 kilos with full tank. And there are two number of nozzles, and the nozzles are adjustable. And for the electrical components, I will explain in the next slide. So here are the electrical circuit diagram for the spraying module. So first, we use Arduino as the main controller to control all the components, and we use a 3S LiPo battery to power up 12 volt diaphragm pump. So because it is 12 volt of pump, we need 3S of LiPo battery. So the battery capacity is 2200 mAh. So it is calculated that the pumps can run safely non-stop for approximately half an hour at 3 amps. So the black part, the black driver, is the MDD3A motor driver, which can regulate voltage to permit the pump so that there are no overflowing of voltage and current. So it is the only driver that is suitable to allow currents flow at 3 amps. And next is the HC05 Bluetooth module. So this is to control the pumps from phone application. So we continue. So here is the flowchart on how the Arduino is programmed, and on the right side we have the phone interface for Bluetooth application to control the pumps. So how it works is by, if circle button is pressed, the pump will operate at 12 volt, which is at full power, and if triangle button is pressed, then the pump will operate at 75%. If square button is pressed, then the pump will operate at 50% speed. And so, however, if X button is pressed, then the pump will be turned off. And that is the finish of the program. Here I would like to show proof on that the pump is operating at how it is programmed. So next, here is how we attach and reattach the spraying module to a multi-rotor drone. So first you have to remove the bolts at the bottom of the spraying module, and then you slide the hanging part, take it away, and slot the holes of the hanging part inside the rods of the multi-rotor, and when you slide it, you attach the hanging part to the spraying module again, and lastly you tighten the holes that have been slotted. So now I will begin on explaining on how I set up this experiment. So first, what I did is suspend the spraying module at the bottom of a clothing rack to test the spraying area performance. And luckily the clothing rack height can be adjusted, so it can be a variable to suspend the module at 140 cm from the floor to the nozzle and 100 cm from the floor too. Then test at variable speed for each height like we did before, and then the color of water is based on the speed that the pump will be tested. So for example, as you can see on the photo, the red color is testing the spraying pump to spray at 50% speed, and measuring flow rate is by running the pump to disperse 1 liter of water. Then we measure the time taken for the water to be emptied, and here's how the experimenter is being set up. And as you can see from the video, the floor is red so that we can measure on the spraying area. And next, this is how we test at 100 cm height of the spraying module, and this is tested with blue water to test at 75% speed. So now we continue with how we set up the experiment. So as you can see, the area will be measured by referring to the color of the floor and by measuring its length and width, and you can see from the photo that I was measuring using a measuring tape the green colored area floor. And then simulation is done by getting an assistant to push the clothing rack while pump is running at multiple speed. So as you can see from the photo, this is my little sister. She's pushing the spraying module. So now we proceed with the result and discussion of this research. So one of the results that we get from the experiment is the volume flow rate performance based on voltage. So as you can see from the graph, the higher the voltage that was run to the pump, the higher the volume flow rate. So this is a correct result because the hydraulic energy is applied to the system. For example, we assume that voltage is equals to pressure, current is equals to flow rate, and resistance is equals to the pipe resistance. So for example, if we increase the number of voltage but maintain the resistance, the current will increase as well. So this is the same goes for the hydraulic circuit. When the pressure is increased but the pipe resistance is maintained, the flow rate will increase. So second result we get is the spraying coverage concerning the height and the voltage. So as you can see, we got two tables. One is tested at 140 centimeters height, and another one is tested at 100 centimeters height, or from the floor of spraying the module. So as you can see from the table, that the higher the receive pump voltage, the bigger the spraying area covered. And from the graph, we can see that the higher the spraying module is spraying from, like for example 140 centimeters, the bigger the spraying coverage area compared to the 100 centimeters spraying coverage area. So next, here's the simulation of the spraying module spraying while it is moving. 1, 2, 3. Okay, push. Faster. Okay, this is at 50% speed. Lagi kuat, full. Amna, tarik balik, Amna, tarik. No, pull back, reverse. Okay, 75% speed. So from the simulation of the spraying module spraying while it is moving, we can see that when the pump is operating at all speed, it works well, and the pump speed will have an effect on the sound as the pump becomes louder, and it also sprays water bigger in terms of the width. And also you may also notice that wind may also have influenced the water to divert its direction of the spraying. So if the spraying module is attached to a real drone, the outcome of the spraying might be different. And now we have found the estimated total cost of the spraying module. So as you can see on the left table, this is the total cost to build the spraying module, and this item listed, this price can be gathered from an online shopping website, and adding all the total cost of the parts, the total is Rm 246 ringgit to build the spraying module. And on the right side, on the right table, we can see the total cost of an agriculture drone with the spraying module attached to it. So the total cost 5,301 ringgit, and this is an achievement because we achieved the objective that to make an agriculture drone cost less than Rm 10,000 ringgit. So here I made some comparison of spraying module price with other agriculture drones to show how valuable this spraying module plus Terra S6 is. So as you can see, it has the cheapest in terms of price to performance of the spraying performance ratio compared to M8 Pro. This one has the biggest gap between the spraying performance and the price because it is the most expensive. So if a user were to use an agriculture drone only for spraying crops, then the most valuable will be the spraying module plus Terra X6. So here are the significant of works that we have found throughout this project. So the first one is that having modules based on the agriculture application for multirotor will save for more money for the users, as it is based on what they want. So they have a choice, either they want to buy lots of modules or only one module, such as the spraying module, to spray their crops. So it saves money for them. Modules with their own working system will make it easier for users without drone knowledge to use it with a multirotor. So as you know, drone knowledge is very difficult to find, so they might not know how to integrate the electrical components. So by having modules with its own system, they just have to attach the hardware with the multirotor. So next, we found that it is essential to note at what height and operation setting should the spraying module be working. So for example, if you want a more precision spraying, the operation should be done at a lower altitude to avoid a more dispersal of the spraying area. And besides that, if we operate it at less voltage, then we save less flow rate, so therefore saving more water. And now we have come to the conclusion of this presentation. So to recap, the spraying module is a device that works separately from a drone and can be controlled wirelessly from a phone application using a Bluetooth connection. This device is also a user-friendly device as it only have one operation, which is to spray crops or liquid pesticide. Besides that, having modules would make it easier for farmers to decide on what the agriculture application they want for their agriculture drone to save more costs. And besides that, all the objective and hypothesis is achieved. For example, we have managed to make an agricultural drone that costs less than Rm 10,000 ringgit and the spraying module weighs less than 5 kilograms. For future scope, since we are living in the pandemic situation, the spraying module can be modified to sanitize a large area where there are many positive COVID cases without being there in person. And now finally we have come to the end of the presentation. So I would like to say thank you very much for listening to my presentation, and if you have any question, feel free to ask on the question on the YouTube comment section below, or you can just contact me in person. Goodbye.